Sine and cosecant are flips of each other. So all you have to do to go from sine to cosecant is turn the number upside down. So cosecant is 1 over sine, which is 1 over 3/7 in this case, which is 7/3. The flips are really easy. You just turn it upside down. Now that might lead to a root being on the bottom sometimes or whatever, but you've dealt with that stuff all year and you can handle it. So you've got identities that you can use to go from one trig function to the other, or you have flips to go from one trig function to the other. Let's try another identity. See if you can do that one. This is an identity question. So we're going to use that identity. 3/5 goes in for cosine. 3/5 squared is 9/25. Subtract that to the other side. 16/25 square root plus or minus 4/5. Since we're in the first quadrant, it is positive. This one's different. In this one, we are starting with cosine, and we're going to cosecant. Now, on your Courtney Pierce, you will not see any identity or flip that has a cosine and a cosecant in it. This is where things start to get fun. What you have to do is you have to create a plan to get from cosine to cosecant. You can't get there directly, like the last two where we were able to use an identity or a flip to get straight from one trig function to the other. This one takes a little more work. Does anybody see a possible way to go from cosine to cosecant? What's your idea?
Take cosine and put it into sine, and then...
Okay, what he's saying is start with cosine, turn it into sine using the identity, then flip it, and you get cosecant. You see what he did there? Kind of a double whammy. Using an identity to get sine, and then a flip to get cosecant. Why don't you see if you can do both of those in this problem? First one's going to be an identity. So cosine squared plus sine squared equals 1. 1/3 in for cosine. That's 1/9. Subtract it to the other side. Like so. Square root. I get 2√2 on top. We know how to simplify roots. And 3 on the bottom. That was all chapter 6. That was first semester. Christmas time. So that's the answer for the first leg of our journey, going from cosine to sine. It's 0 to 90, so our sine is going to be positive. And then to find the cosecant, we have to flip it. Now we have a root on the bottom. So we have to rationalize the denominator, get the root off the bottom, multiplying by √2 on top and bottom. The stud answer for this question is 3√2 over 4. So you can see how we had to do 2 steps. And the thought process that you're really trying to master today is coming up with that plan to go from one trig function to the other. Okay? Now, let me show you something that I've put on the Courtney Pierce for you. So we've been given the cotangent, and we want to find the cosine. So if you look at the circle on your Courtney Pierce and start at the cotangent, you will see there are 2 paths to get from cotangent to cosine. you can either go cotangent, cosecant, sine, cosine. And that would be identity, flip, identity. Or if you go the other way around the circle, it would be cotangent, tangent, secant, cosine. And that is flip, identity, flip. Do you have a preference? You like flips better than identities? Okay, me too. So we're going to go with flip, identity, flip. We're going to start with the cotangent, and we're going to keep moving until we get to the cosine. Okay, that's our plan. We've come up with a plan. You cannot go straight from one trig function to the other. You have to accomplish small goals in between before you get to the solution to the problem. All right, so the first thing I'm going to do is flip it. There we go. I've taken care of one thing already. Tangent is 2/3. Simply by turning it upside down. The next step requires an identity to go from tangent to secant. So you have to find an identity that has tangent and secant in it, and there is one. 1 plus tangent squared equals secant squared. Our tangent is 2/3. So 2/3 is going in to the tangent area. Two-thirds squared is 4/9. Remember, I don't like mixed numbers. I don't like decimals, so you need to give me an improper fraction, 13/9 for secant squared. Square root both sides. Plus or minus root 13 over 3. Again, we're in 0 to 90. We're not always in 0 to 90. It's just the way it's been so far. And so secants, to figure out the sign of a secant, you look at the sign of its flip function. The secant is the flip of the cosine. So in the first quadrant, cosines are positive. So that means secants are positive. So you look at the trig function that's on the unit circle, cosine, it and its flip are going to be the same sign. So it's positive, so the secant is positive. So at this point our answer is root 13 over 3. And now to finish the job, all we have to do is flip it. And then we have to get the root off the bottom. Final answer, 3 root 13 over 13. All right? That's about as long as the problems get of this type. Flip, identity, flip is about as much as you have to do. Unless you choose to go the other direction. My plan is to go sine, cosine, and then secant. Could have gone the other way. That's longer. So I'm going to go sine, then cosine, then secant. Is everybody seeing their way around the Luther circle there? So with the identity, I get 24/25 for cosine squared, square roots, plus or minus that. In the end, you get 2 root 6 over 5 for your cosine. And then to find the secant, you would flip that. 5 over 2 root 6. Have to rationalize that denominator and get 5 root 6 over 12.